Okay, so today we're going to learn about finding the slope of a line specifically and how it relates to rates of change. All right, so I want you to take a look at the sheet that you have for your notes. And so the first situation, we're given the side view of two ramps at a local skate park. And then, so here they are, ramp A and ramp B. This is the side view. And they're both right triangles, if you notice. So let's answer these questions. It says, what measure do the ramps have in common? Do you notice it? Yes. The height. They both have a height of 8 feet. Okay. So that height is 8 feet. The vertical distance is different. So can you get the door, please? All right. So I'm going to call this, actually, I'm going to call it vertical distance. And it's 8 feet. So they both have a vertical distance of 8 feet. And the ones they have that are different is the horizontal distance. You see that? One is 12 feet, the other is 8 feet. And one was 12 feet and 8 feet. Okay. So here's the key question, the last one. Just by eyeballing it, and maybe you can back it up mathematically, ramp A or ramp B, which appears to be steeper? Okay. Why? What do you think?
Because like the ratios height or vertical distance and horizontal distance compared to each other is only 1-to-1.
Mm-hmm.
And then for the vertical, for ramp A, it's like a 1 1/4, I think.
Yeah, okay. So that's very good. So let's go with ramp B. Ramp B is definitely, absolutely steeper. And if we look at the ratio, like you said, of vertical distance to horizontal distance, it's 8 to 8, which turns out to be 1-to-1, or just 1, versus, let's figure out the vertical distance to the distance here. For ramp A, what's the ratio of the height to the horizontal distance? 8 to 12. And we could probably simplify that to, let's see, 2 to 3. Can we simplify it that way? Since 4 is yeah. So we're comparing 1 to 2/3. And which one's greater? 1. All right. So basically, this is introducing the idea of slope. So when a linear relationship is graphed, the slope is a value used to describe the what we call steepness. Steepness of the line. So it measures how steep a line is. That's the main thing what we'll be using it for. Later on, when you get into other level math classes, you're going to not only be graphing lines, but you'll be graphing curves. And you'll find the steepness at any point along the line, because the steepness is going to change as you move along the line, or the curve rather. So, okay, so the slope is the ratio of the vertical change compared to the horizontal change. Or what we like to call, and you will too, rise over run. Rise over run. And we'll be using this idea of rise over run quite a bit today. So basically the slope is equal to the change, to the rate of change rather. So last year we did a lot of work with rates of change, but it's a rate of change of the graph and the linear relationship. So it's important to understand that a rate of change and a slope mean the same thing. They basically mean the same thing, except slope has to do a lot with graphs usually when we're graphing things. And there's 4 different types of slope. And so we're going to examine those right now. 4 different types of slope. And here they are. So look at this first graph. Do you see how the line increases from left to right? It's going, would you say, call it uphill or downhill? If you're looking left to right, left is here, right is this way. If you're moving in this direction, would you be moving uphill or downhill? Uphill. So we call this an positive slope. So left to right, that's the key. Left to right. If you're going uphill, that's a positive slope. Now if we're looking left to right and we're going downhill, that's going to be called a negative slope. So we can have positive slopes, negative slopes. And then we have these 2 unique cases. Most of the slopes will be either positive or negative. So a line, more likely than not, will either be going uphill, left or right, or downhill. But every so often, you'll have a perfectly horizontal line. Okay? If you have a line like this one that's perfectly horizontal, guess what the slope is there? It'll be 0. Okay? So it kind of makes sense. If this is my line, I'm going to use my pen. That's positive, 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 positive. At some point, it reaches a perfectly horizontal zero slope, and after that point, it's going to be negative, 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 until it does this again, till it's perfectly vertical, and then we're in this case. And then if you have a perfectly vertical line like this one, this slope is called undefined. So you can have positive slopes, negative slopes, and that will be most of the cases. Every so often you'll have a zero slope or a undefined slope. Okay? Any questions? Okay. So now our main goal is to find the slope on a graph. Tomorrow we'll find the slope using coordinates, but today we're going to find the slope on a graph. Okay, so here we go. So what we want to do, if we have a graph, like for example this one here, we want to find 2 points. We're going to choose 2 points on the graph, or in this case a line. And basically what we're going to do is kind of like what that ramp looked like. We're going to draw a right triangle and count the rise. And the rise is how much you go up or down. And the run between the points. And the run is how much you move horizontally across. Okay? Because I want you to think about right triangles. Here's a couple of right triangles. So here we had a rise of 8 and a run of 12. Here we had a rise of 8 and a run of 8. So on a right triangle, you have a vertical segment and a horizontal segment. And that's what we're going to be looking at. So what we're going to do is we'll set up a ratio of the rise to the run. It always boils down to rise over run. And then if we get a fraction that we have to simplify, we'll simplify it. And then we're going to double check if the graph is positive or negative. So we'll practice here. So we got this line. It has some sort of a slope. Just by looking at the line, should we expect a positive slope or a negative slope? Positive. Should be positive. So we'll see. So we're going to pick a couple of points. Now you got to be careful. You want to pick points that cross perfectly on the hash marks. So I would not pick a point like kind of in between like this. I wouldn't pick that point. This is a good point right here. This point at 2 would work. So at 2, 4, I'm going to make a dot here and maybe here. At 4, 8. I'm going to pick those 2 points. So go ahead and pick those 2 points. I picked one at 2, 4, and 4, 8. And here's what you want to do. My recommendation. You want to, once you decided on 2 points, pick the point furthest to the left. Furthest to the left. So that's this one. 2, 4. And then we want to figure out the rise and the run. The rise and the run. So let's do that. Rise and run. So I'm going to go from this point to that point, but I'm going to rise and then I'm going to run across. So the rise is this much. How much did I go up? How many spaces? 4. 1, 2, 3, 4. So the rise was 4. And then I want to figure out the run. How much did I go to the right? 2. So the run was 2. And the slope would be the ratio of those. It would be the rise over the run. So it would be, well, other way, it's the rise is the top number and the run is the bottom number. It's 4 to 2. And then you simplify it. So 2 to 1 or just 2. So the slope of this particular line is 2 or 2 over 1. And it makes sense because look, if I go up 2 spots, 1, 2, and over to the right 1, I'm back on the line. Go up 2 spots, over to the right, you're back on the line. Okay? Any questions? So that's what we're going to practice on that next page, just finding slope by looking at a graph. All right? So let me know if you're ready. We'll move on. Okay, let's move on. Okay, here we go. So we're going to find a couple of good points. First of all, what do you notice? Positive slope or negative slope? Negative. So we should expect a negative number, and we'll see. So I'm going to pick this point. That looks like a good point. And I'm going to pick this point. Those 2 points. What do you say? Okay. So they're nice and close together. So remember, always start with the point furthest to the left. So I have these 2 points. And let me zoom in a little more. Okay. Now, we're going to go down. We go down 1. Since I went down, guess what number I have to use? Negative. That's going to be -1 because you go down. When you go down, it's negative. When you go up, it's positive. When you go to the right, it's positive. When you go to the left, it's negative. It makes sense. Now let's do our run. We're going to run to the right. So that would be +2. So our slope would be -1 over 2. And we don't have to reduce this. It's just -1/2. Down 1 over 2. Okay, so the steepness of this line is -1/2. Okay? Okay, the next one. What is our slope for the second one? 0. It is 0. Let's see why it's 0. There's a reason. Let's say, oh, they didn't give us an undefined one. Okay. Let's say we're at this point and we want to go to this point. Okay. What's our rise? To get from this point to this other point, how much do I go up? And then I would run 2, right? I would go over 2. So the rise would be 0. The run would be 2. What's 0 divided by 2? 0. That's why it's always 0. Your rise was always going to be 0. Okay. Let's try the next one, number 3. It's positive. That's my first question. It's positive. Pick a couple of good points. Maybe this one. So I'm going to pick 1, 9, and what is it? 321. Okay, we got to be careful though, because you notice on the y-axis what's going on. Yeah. So let's do the rise, but we got to go by 3s each time we move up. Okay. So each time I go up, I'm not going up 1, I'm going up 3. So this would be up how many? 12. And the run, look at the x-axis. What's our skip count by ones, right? So that would just be 2. So we're not going to do 4 over 2. We're going to do 12 over 2. And what's that going to give us? 6. So that would be 6. Okay, any questions? Let's try number 4. Number 4. Looks like our scale is the same on each by ones. So let's pick a couple of good points. This one at -2, -6. And where's another good one? I know this one works for sure. Sometimes even if they're a little far off, it's better to be safe than sorry. Want to make sure I know this one works, I know that one works at 2, 0. So again, pick the point furthest to the left, and we're going to rise. Let's see how many we rise. Count the spaces. 1, 2, 3, 4, 5. That's positive 5. And oh, I missed one, didn't I? 6. Let's change that to a 6. So our rise was 6, and our run was 4. So what's our ratio that we want? 6 to 4, which we can reduce. Okay. 3 to 2. So we end up with 3 halves. Okay. All right. So look at the numbers as we're doing it. Let's try this one. It's positive. We'll pick a point here. It looks like we're skip counting on the y-axis by 2 now. And we'll pick this one here. So let's see. It's positive, and we're going to go up 1 space, which is how many? 2. It's 2 units. And then we're going to go to the right. 1, 2, 3, 4. So what's our ratio? Rise over run is 2 to 4, or 1/2. Okay. So far, most of them have been positive, but not this one, right? We got a negative slope. And where is a good point? -2, 1. Yeah, that's a good one. And then another one at -5, 5. 1, -3. Let's go with that one. And then we said -2, 1. Let's do those 2 points. And remember, start furthest to the left. So this point. And then we're going to go down. So that's going to be, if we're going down, that's going to be -4, And then we're going to go to the right. How many? 3. So that would be -4 to 3, or -4/3. Okay. All right, let's do the last two. Luis thinks the slope is 1/2. So Luis made a mistake. Let's correct it. Let's figure out what it actually is, and that way we could figure out what he did wrong. Hmm? As long as there are points where it crosses perfectly. So we could have picked this point, right? And then we still would have gone down 4 and over 3. So if I would have picked that -5, 5, you're still going down 4 into the right 3. Yeah. What you don't want to pick is points where it doesn't cross perfectly. Okay. So he said it's 1/2. I think I see why he thinks it's 1/2. He literally went up 1 and over 2, right? Yeah, the scales. So let's see. Let's pick a couple of points. This one and this one. He went going up 1 in this case means what? Yeah. So it's 5 to 2. So 5 to 2 is the actual slope. What could we say he did wrong? Luis did not read the scale on the, which axis did he not read the scale on? Y-axis. All right. Okay, last one. So the graph shows the linear relationship between the number of bagels a bagel shop has remaining and the number of customers served so far that day. Find the rate of change of bagels remaining with respect to the number of customers served. So we have bagels remaining, that's on the y-axis, and the number of customers. So as you notice, this is going down, that one's going, so it's negative, which it should be. Because the more customers, in theory, the less bagels you should have if you just bake them in the morning and that's all you have. Okay, so let's see here. Let's pick a couple of good points. Maybe this point here and this point here. And let's see what that gives us. So on bagels remaining, it went down by how much? -50. Oh, I'll just. Okay. And then customer served is across. That went, what's our scale by there? 10. So we would be looking at -50 to 10. Yeah. So it's 5 bagels every customer. So it's -5. Think about this. This is -5 to 1, right? 5 bagels down for every customer served. So every customer that came in, about how many bagels were they buying? 5. -5 bagels per customer. All right, guys. So the assignment is on Delta Math.